So MongoDB is a database engine, and as you can see on the title card, it is a NoSQL database engine, specifically a document database style of storage. What that means is that rather than using your standard SQL SQL query language to get back records and store things, you use other versions of that. So in a comparison with your regular SQL, your SQL databases are going to store things as individual records that are a part of a table. So when you define your schema, you're going to end up with some table that has some number of columns, that have some data type. Okay, probably going to be some sort of ID that has an identity, or that is an identity that is an int type. Some strings or other things that are getting stored. With NoSQL, most NoSQL databases, this isn't actually applicable to all of them, I guess, but for Mongo in particular, everything is stored as a document. More specifically, as objects in a document. So rather than having a table that stores individual records, we have a collection that stores these object documents, and they can be pretty much anything you want them to be. And I've got some examples later that I can show us how that works. So rather than being some column that has a defined type that says this is going to be this field and has these requirements, all that stuff, these are free form, whatever you want to plug in at any point in time, and the collection will just accept it. So their storage schemas are extremely different, and you have to deal with that in your code. Queries done in SQL, obviously for SQL. Queries are done using object requests in NoSQL, meaning you pass in a field with a value, and it'll go through and grab all of the records that have the field with that value. SQL, everything is referential. So if you want to have some piece of data that is tied to some other piece of data, you use tables to do that, and you're going to store some foreign key in one, or you're going to have some link table that combines things from many to many. With NoSQL, everything is non-referential, meaning you typically don't do that. If you're going to store related pieces of data, you're usually going to store them in one object together. You can do referential pieces of information, but generally it's not done that way. SQL is much faster at any sort of data mining or reporting, anything that is about metadata. SQL is considerably faster. NoSQL, however, is quite a bit faster at indexing and lookups. So if you are concerned about getting fast data back and forth between whatever service you're calling in your database, NoSQL might be the better option. Versus SQL, if your company or whoever you're doing things for is looking at, I want to get this data from our users and then be able to mine it to make different decisions about things, SQL is going to be better at handling that. So obviously the right technology for the right job, but there are advantages to both. So Mongo itself, its engine, is using a JavaScript runtime, which means anytime we want to do any sort of scripting, database management, any of that kind of stuff, we're going to be using JavaScript, or at least a sort of stripped down version of JavaScript to do that. Document imports and exports are done with Beus. If you're familiar with JSON, okay, it's a JavaScript object notation. Beus is the same thing, except for it supports binary data. Otherwise, it's the same format. And then documents, as I mentioned, are dynamic, which means at any point in time, if I want to put one type of record into a collection and then some completely different unrelated record into the same collection, I can technically do that. So it's best to keep things consistent, but you can. And then, as I mentioned, objects can contain sub-objects. Okay, so let's get out of the slides, because I always hate slides. So I have a series of databases I've been using as I teach school. We can look at a couple of these. But as you can see, they look for the most part like your SQL tables or SQL databases. This is for my advanced JavaScript class, so we'll look at this one because it's going to make the most sense. But if we look down here in collections, again, you can look to see these look kind of like your tables. If we look under lists, we can look at indexes, and that's kind of where the similarities stop. Otherwise, you'd be able to see columns and things. But if we look at lists, you can see it's just a regular query, and I can display this as your general, your typical table entries that you're probably used to. Notice it has a name. It's a column. So blah, 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 blah. This is just dummy data, so I could show my students. So everything looks for the most part the same until you get to this items section. So we come back here, this one object, what we would normally store in SQL is just the name and the ID. But inside here, I actually have a sub-collection, which is an array of other objects that have data. In this case, it's just strings, but these could actually be bigger objects and bigger pieces. To do the query, if we look up here, we're just going to reference our database and then say get collection lists, and then this dot find, and then it might be hard to see, but these are actually open and close curly braces. So if I now want to find one that has the name my list, what I would do is give it a property or a field of name and give it the value my list, and if I execute that query, okay, it'll filter down from those 3 to the 2 that have this same name. Okay, so the end result is the same where you're storing records, but the way you actually do it is slightly different. Again, you can have sub-items, you can have different data, whichever. Here you can see inside this we have name and items. If I decide that I want to then insert something that's completely different, let's do type and let's do manufacturer. Yep, that's right. And let's do model. Okay, so I can just create this JavaScript object, this JSON object, by just typing in whatever fields I want it to have and whatever values I want it to have. Hit enter, and you can see it does accept it. Now if I do a .find again, okay, I've got some more records, and you can see this bottom one now looks very different from the rest. However, it's happy to keep them in whatever form that I want. Okay, so in that case, we can look for things, and if I say name equals my list again, actually let's just do users. Okay, notice it doesn't have a problem that that record doesn't have those fields. It's able to skip by it and say whatever, we can just filter those out. If we go back and say manufacturer is Ford, okay, again, it doesn't matter that the rest of them don't have this. It's happy to find the record that does actually match up. So along with this, you might ask, well, how do I just get things that have that field rather than having to know the actual value? And there are a bunch of new operators that you would have to know. One of them, again, you're just going to put in the field that you want to worry about. Okay, and then you can make each one of these a subquery with some of these little extra things. So what I can do is say, give me all the records where the manufacturer does exist. Did I spell that right? No. There we are. See, and it correctly told me no, there aren't any. There we go. Okay, so it's able to find this, and again I can say, all right, give me something where the name exists, and it'll give me the rest of them. So even if we're storing everything in the same collection that's disparate types of data, we can actually get information out of them that's useful. I'm going to go through Visual Studio Code before I do anything with these, but I can show you how these integrate with websites and how you can query them and do other things with more code. Let's see. Well, yeah, we'll come back to that. All right, everything else. Actually, I don't think I have anything. Nope. All right, let me create another quick record. So let's do another type. Let's say this one is going to be GM. And let's say I want to actually have a series of sub-objects rather than just one single value. So what I can do is actually create an array and then put separate objects inside here. So I can say name, what's a GM model? Sierra. Let's say cost, I have no idea. Okay, then I can add more of these. I'm going to scroll off the screen, but it'll work out. I know there's a GMC. I should know these, I work with vehicles. And we'll say that one is 35,000. All right. Probably helps if I, insert instead of try to find. Okay, so now we got some extra records here. So we can look at this new record. And again, we can see, rather than having my GM record that has information about GM, then having a separate table that has information about the different models that GM sells, I can actually use those to contain information within that one record. So let me ask a seemingly simple question. Why do we put things in separate tables with referential databases? Okay, so we don't want to repeat ourselves. There's also another term we typically use. Okay, we want to use the normal forms, right? We want to normalize our data. So if this were a regular table, this GM record, we wouldn't know how many model entries to put in that same table because we may add some later. So instead, we put it in a different table, and away we go. Then, of course, we have that table have a foreign key, and we record it that way. How likely is it, though, that those separate records are going to be used by anything other than that one GM record? Okay, in this particular example, I would say not likely. If any other company tries to create a vehicle named Sierra, GM is going to be a little pissed and come after them. So with NoSQL, we don't have that restriction. Because those records are going to be only used for this one piece of data, we can actually group those together, put them in, and now when I want to look at this, I just query this one record, and I get all the information I need about that record. Okay. Then if I want to query stuff, let's say I had more than one of these records, I can even do things like model.name. Like so. And you can see it's able to find the record that has a model subobject with the value of Sierra in its name.